Okay. So, the first thing that we're going to talk about that we didn't have a chance, I think we got to, did we get to 1 second difference in the note?
So we talked about having
Did I show you an example?
Yes.
Okay. Let's just recall what a second difference is. Remember, we could have something like this. Okay? Notice it's already consistent, isn't it? With that being the case, that means it's a constant, meaning it's just a horizontal line, right? Meaning x to the 0 power, because it's on the 0, meaning it's already showing you right up that this is not changing. Oh. Yep, right over on there. Does everybody understand that? Okay? So this one would be constant, because notice 0, 0, 0, 0, meaning it's already consistent before I even moved it, right? Okay? We could also have a linear. Ooh. Okay, so like 4, 7, 10, 13, 16, right? Where this isn't consistent right now, but on my first difference, it is constant. Notice because it's on my first distance, that means my degree would be degree 1. Yes, no, maybe no. Okay. Then, the one that we did in class might not be exactly the same, but bear with me. That's a good one, whatever that one. All right. First difference. Is it exactly the one? Close enough. 5 to 2. What do? We went down 3. Right? 2 to 1. Down 1. 1 to 2. Up 1. 2 to 5. Okay, so is it linear? Is my first difference constant? No. Never there. Is my second difference constant? Let's check. We went up 2, up 2, up. Is it consistent? So therefore, it's on my second difference. Hey, no more sling. Feeling okay? Better? Good. My second difference is constant. So therefore, this makes it a quadratic. Okay, what if it happened on my third difference? Cubic, fourth difference, quartic, and so on. But then obviously, if you have a quartic or something raised to the fifth power, you're going to need a whole lot more points, right? So you can see that happen. Any questions there? You find them pretty easy? Okay, just throw them right in front of the cart right here. And then if you'll ask Sharon again to just open up that room and put the card away for me, okay? Thank you. Everybody questions on the differences? Do we feel more comfortable about the differences now? Pretty simple. All you gotta do is this. You'll see the homework. I'll give you a chart just to see which one. Okay. Now, the other things we talked about is 1. How do we know the degree? Go ahead, Curly. 1 more than the turning point. That is correct. That is actually a technical thing. But if I gave you the polynomial instead of a graph, it's the greatest exponent is the degree. Correct? Remember, if it was like 3x cubed plus 2x squared, it would be the 3, wouldn't it? Okay. How do I find my turning point from a polynomial? I find my degree and subtract 1, and that'll tell us the most there could be, correct? But there could be other options as well. Remember, if it's x cubed, I could have 2 or 0. Remember, it goes down in increments of 2, right? Turning point. Okay? We could have done that on our homework. Okay? There's a couple other things The other thing that we didn't get time to, hopefully you have your calculator today. If you do, grab that out. It asked about increasing and decreasing intervals, correct? I believe in a couple times here. Okay, we're going to show you that how to do that right now. Okay. Pull over. So I'm going to pull up my machine. Now, I have a TI-84. That's what's going to be on the screen. If you have a TI-85, 86, okay, I can help you with this math in the class. If you have a Casio, you're on your own. And as you were last year, right, Hadley? Okay. But, please, not saying that they are bad machines. Casios, the reason why TIs are used in this stuff a lot, because TI comes in and trains us how to use their calculator. Casio doesn't do so. Casio is just an equivalent, it's actually a cheaper calculator, but it's just as good. But we don't know how to use it. So TI puts the money into the state of Utah, hence we're like, we use TI, so you should buy it. It's called marketing. You know what I mean? But really, if you think about it, it's very smart on TI to put a little bit of money into it, and that's what we're going to use. So there's still more calculator. But not saying it's bad. So I just want to make sure you guys understand. I'm not prejudiced about the other ones. I just know how to use these ones a lot better. Okay? And you're more than welcome to do everything I think I'm doing in here on those other calculators. You just might have to research it via book or Google. I was helping a girl just the other day with her TI-85. It's not as user-friendly as the 84. Your 83 is just equivalent to this. It just might not look exactly. All right. So we're going to go ahead, and I'm going to write an equation first. Let's go to here. This is the equation I'd like us to go ahead and plug into our calculator. Okay. We're going to plug that into our calculator on our y equals. Now, really quickly, let's just talk about this really quick. What should this graph basically look like? Well, we should know our end behavior, right? Because it is an x cubed. We know it's this so far. Then, that's just going off the x cubed, correct? Then we look at the leading coefficient. Because it is positive, we still have this direction. But once again, what if our leading coefficient was negative? What happens? We flip, don't we? Same thing if I had x squared or x to an even power and negative even power. Okay. Any questions on how I kind of got, I know it's kind of like something of that case. Once again, it could have two turning points, something of that, right? Everybody there with me? Okay, so we're just going to get a general rule, but we are going to kind of graph it a little bit more accurately. Here we go. Okay. So for all those you're going to hit y equals. Okay, I have something here, so I'm going to clear it out. So I'm going to do 4x is right here, caret q. Push over, plus, is it 3x squared I did? Okay, that's as big as I could get that. I'm sorry, I wish I could get it a little bit bigger. Maybe I can. You. Show larger display. Oh, there we go. Okay. Now, I'm going to go ahead and hit graph. Well, let's actually do something first. This is going to give me a graph, but then let's all have the same thing. So let's hit zoom. Notice if you look at number 6, it says standard. So I'm going to hit zoom 6, and then we're going to look at all the same thing. Here he comes. All right. It's hard to see, but you guys see how he actually has two turning points. He does come up, and he comes back down and goes back up, right? You guys see that? Very hard to see, so maybe we want to modify our window. I'm going to hit my window, because we're on our standard window, which went negative 10 to 10, and negative 10 to 10. Make sense? Now, is every graph visible off of a standard window? No. So we might have to adjust it, right? So that's what we're going to be doing now. I'm going to zoom in just a little bit, and I don't like the zoom in tool. I don't. So I'm going to actually physically change it. So my x min, what does x min mean? The smallest x value that I'm going to be viewing, right? Enter. I'm going to go to 5. The scale means what tick marks they're going to be marking. That makes sense for everybody. And then now I'm going to go y min, I'm going to do -5 to 5 as well. And I'm going to hit graph again. So just a little bit better view. I can see my high point and my low point just a little bit better than I did before, right? Everybody there was comfortable. Okay, so really quick, how many intervals are they decreasing? How many intervals is there decreasing? One. Only one. And that spot is from that high point to that low point. Because from here, this right here is what? As my x values are getting larger, so are my y values. As my x values are getting larger, so are my y values. But in between these 2 points, as my x values are getting larger, my y values are going down. So that would be a decrease. So understand we have 2 increasing sections and 1 decreasing section in this graph. Correct? Any questions so far? Now, I would like to know what is that high point and what is that low point. Really quick on the question before we get into it. Let me talk about going up and down the stairs. If I'm at the bottom of the stairs, am I increasing? No, I'm just at the bottom of the stairs, right? What makes me start increasing going up the stairs? Physically making that first move to step onto the first stair, right? What makes me stop increasing? When do I stop increasing when I'm walking up the stairs? When I get to the top, right? When I'm at the top, am I increasing? When I'm at the top, am I decreasing? I start walking the stairs. No, I'm still there. It's not until I make the movement to move. So let me ask you this question. Do I include or not include, so meaning bracket or parentheses, on the intervals for the high and the low point? Do I include them or not include them? I don't, because it's all the way up to the top. When I'm at the top, I'm not doing anything, am I? It's when I start going down. Does that make sense to everybody? How it's not included? Very important to understand. Okay, so let's go ahead and find this low point first, right here. Okay, we're going to find that low point. How do we do so? We're going to not do trace, because trace is not accurate. Trace is not accurate. Okay, are they values on the graph? Yes, but it's not going to give me directly the low point. Okay, so I'm going to go second, calculate. It's right above trace. Notice, what did I want to find? The low point. What is that low point called? A minimum, huh? That's a low point. So I'm going to do number 3. Now, look at our instruction. What does our first instruction ask us to do? Left bound. What does that mean? I need to be the left of that minimum. Okay, so what I'm going to do is I'm going to push to the left. See how my cursor is moving? See how I'm up here? Am I to the left of that low point with my cursor? I am, so I'm going to hit enter. What is our next instruction? Right bound. So what does that mean? Move to the right of that low point. Just as long as it's to the right. I always like to make sure I am visually far enough over. Does that make sense? Answer your question? So I hit enter because I can see I am to the right of that low point. Now, this is the nice part with your Casio. It's a lot nicer on this than what I have to do, isn't it? I think we found that out last year. She hits the button, it goes whoop, and it goes right to it. So, once again, it's just a different thing. Okay, so I hit enter, and then it tells me guess, just hit enter again. On the guess, don't worry ever about the guess. Okay, now this says negative 2.923e to the negative 6 and 2.56e to the negative 11, which is such a small number. Guess what it really is? 0, 0. That coordinate is 0, 0. How many of you guys got 0, 0 instead of all that stuff? And really, guys, it depends upon what we actually put in our calculator as we have our bits. Like, I don't know exactly, I'm not a computer guy or whatever, but you can make your trace go by specific increments. And that's the reason why I give us this. But it's just basically 0, 0. Is everybody there? So I'm going to come over here. Oops. And I'm going to graph that I know that this point is at 0, 0, and I'm increasing the rest of the way there. You guys agree with me? Okay, we also have a high point, didn't we? So where are we going to go for that? Second, calculate again, but in this time we're going to do number 4, which is the maximum. So once again, it says left bound, so I'm going to go to the left of that high point. Oh, I'm to the left, for sure, right there. Now I want to go to the right of it. Now, to be honest, because it's a maximum, I don't want to start going back up on the increasing part. Because what it says is it's just looking for the highest point in between these two arrows that's popping up on there. Okay? So I hit enter again. Okay? Notice, is my high point in between these two arrows on top? It is, and that's what it's looking for. So I hit guess again, enter. And I have negative 0.4999, which is basically what? Negative a half, right? Comma 0.25. So, coming back to my graph, here's negative 1, negative a half, 0.25. We'll say it goes there. Everybody see how we just found the high point and the low point? Now, when you're doing this by yourself, you can go a lot quicker. I was just kind of going at a slow pace to make sure you guys understand the plot. Yes? Calculus. So, it's called first and second derivatives. I don't know. Yes, calculus. Okay, everybody with me on that? Good? Okay, so let's go ahead, knowing that we have this lovely graph. Where is our graph increasing? This blue section and that blue section, correct? Those are the two parts that are increasing. So let's write the interval. So where do we start? Negative infinity to negative a half. We use the x value. That's our first interval, right? What's our second interval? 0 to positive infinity. Those are saying, as my x values are getting larger, my y values are also getting larger, right? That's the next question. Are you okay? All right. Where am I decreasing in? Negative 1/2 to 0. Noticing in between that range, as I move to larger x values, my y values are getting smaller, correct? Turtle. U means union, which is an or statement. It's saying this one or this one are in. Okay. How do we feel now? Do you think you could jump at those assignments to finish it up a little bit? Notice second differences, increasing and decreasing. Is there any other problems on your homework that you felt that we needed to go over that aren't one of those things that we taught? Yes, ma'am. Number 30, okay? Number 30 on the 1-1 homework is very close, but it is something that we've learned in the past. So a couple things that says in number 30 is, we have a cubic equation, right? What's our cubic equation when we don't know our coefficients for each term? It is y equals ax cubed plus bx plus cx plus d. Right? That's our most generic cubic equation. You guys agree with that? Oh, sorry. Thank you. You guys agree with that? Most basic. But I believe it gives us our leading coefficient. What is that? Let's say 2. So A is 2. And our constant, which is, what is it constant? 7? I think it was 7, wasn't it? Okay, so that is the information that is given. So I need to find out what B and C is. How am I going to do so? Well, I believe they tell me f of 1 equals 7 and f of 2 is 9. Okay. What do those mean? What does f of 1 equals 7? So instead of y, I guess I should have f of x equals here, right, instead. So I can use the function, right? So what does f of 1 mean? What does the 1 replace? What does the 2 represent? Or the 7 represent, excuse me. The y. So this is a coordinate 1, 7, right? Meaning I can plug 1 in for all the x's and 7 in for the y. So I have 7 equals 1 cubed, 1. 1 times 2 is 2. 1 squared, 1. 1 times b is b. 1 times c is c plus 7. You guys with me on that? Notice if I get everything to one side, if I subtract the 7 and subtract the 2, I get negative 2 equals b plus c. You guys agree with me there? How many do again? Are you okay? Where did I lose you? Do you understand how this is my most generic cubic equation? Okay. Then they gave me my a value and my d value because they gave me my leading coefficient and they gave me my constant. So hence I just substituted. Now, that's where these points come in. Okay, is that enough to help me find B and C? No. I need to have another equation. Can I have another equation? That's what this guy's for, right? He's going to give me another equation, isn't it? So remember, that's 2, 9, meaning 2 represents the x's, 9 represents the y values, correct? Okay, so I have 9 equals 2 cubed, 8. 8 times 2, 16. Any question how I got the 16? I just plug 2 in for x. 2 squared, 4 times b. 4b. 2 times c. 2c plus 7. Notice my equation for that guy, if I subtract the 7 from here, that gives me a 2, and then I subtract the 16, that'd be negative 14 equals 4b plus 2c. And I have negative 2 equals b plus c. I have what we call a system of equations, don't I? I have 2 equations with 2 unknowns. Am I able to find out what A and B, B and C are? Okay, I'm going to let you guys try that just for memory's sake. But anybody want to give a hint on what you could do? There's 2 possibilities, really. Nope, right here. Nope, I'm not dividing anything yet. Okay. Yes, Jane? Substitution or elimination. I could either A, on the bottom equation, solve for C or B and substitute back into the top, right? Or I can multiply the bottom by a value so that I can add the equations together to eliminate, right? You guys remember those? Substitution or elimination. Back in the day, you could have a matrix. This is the first class. Every time I said matrix, you guys are like, I don't know why. It's probably one of the easier subjects Because you guys learned it so early, you're like, oh, I don't know what that is. Oh. Sorry, I'm taking it back. Okay. I'm gonna let you guys finish that off. But then the key goal is that it gives us an f of -2. Is that what it is? Am I right? F of -2 equals what? Well, after I know what B and C is, I can just plug it into the equation and I'll get out my output. Right? So now you go from there though, because that's a little bit more. Because the other part's not the part you understand. I bet you know how to do it. Okay? Sorry guys if I look like I'm too hillbilly-ish today with my green pants. My belt broke today. No, I have my belt. No. Freaking, my belt is right here. And the weld busted. And I tried to hot glue it. Hot glue did not work. So, yeah. And I could be a professional plumber without my belt, I'm telling you what. But we don't want that here in school, do we? Okay. All right. Anything else that you guys kind of, as you were looking through the homework, you probably felt a little bit lost just for the fact that you're like, ah. Well, we did cover everything, right? Okay. Is it Brielle? You're Brielle? Okay. Okay, can you read it to me? Maybe I can get you an idea to start it. Okay. So we have a height that is 3 less than its width. Or excuse me, height is 3 less than its width, and its length is 5 less than its width, right? What are we going to call W? What's our width? W, right? So we're going to say W equals W, or width equals W. So what's our length? So it's 5 less than our width, so W minus 5, right, Real? What's our height? W minus 3, right? And what is the volume of a box? Length times width times height, right? So you have W, W minus 5, and W minus 3. You agree with that? Okay, now what's the rest of the question? So there's our volume, that's question part A. So I'm going to let you try that now that I've showed you how to use it. Now, once again, you might have to adjust your window to get the best view possible, okay? But now that we actually know how to do increasing and decreasing in the calculator. So, once again, we go to our y equals, right? But instead of W, what are we going to put? X, maybe. And then put it exactly like it is. X times, parentheses, X minus 5, parentheses, X minus 3 in parentheses. You don't have to distribute it through if you don't want to, but you could. But the calculator would do it for you. Right? Does that make sense? Everybody with me on that? Besides that, are we good? Do you feel like now with that extra pieces that you can finish the homework? I'm going to have you guys make it due by next time. And I'm sorry that I didn't tell you that you weren't going to get, I knew that you guys weren't going to be able to do it all. I knew it. I thought I said it, but I apologize. But, okay? But today, it is a new day. And a new lesson. Anybody remember what time we get out of here? Like 12:08 or something like that, right? No, we're about to take 12:06, Cosette says, let's see if she gets it right. Oh, look at the paper, it's popping out. 12:06! Cosette's right! Yay, Cosette! Cosette, I see you have braces. How long do you have braces? May. My daughter just got them for the very first time yesterday. Oh, she already said, she's like, I thought this would be okay, but it's not. My mouth hurts. Ice cream and I'm like, I've never had braces. I wish I did because now my inner teeth are kind of popped out again, but whatever. Yeah. She had chicken and mashed potatoes. Well, that came back to me. All right, so today we're going to cover, I'm going to teach you the first part sitting right here. What's a polynomial? Like x cubed plus 4x squared minus 7 could be a polynomial, right? How do I add polynomials? You cry? I hope you don't cry because this is really easy. Combine like terms, right? How do I subtract polynomials? I distribute the negative through, correct? And then combine like terms. Hot dog, guys, this is hard stuff. Then, what do? We multiply polynomials. When I multiply a polynomial to another polynomial, what do? You distribute, right? By multiplying each term into the other term, correct? We've all done this all before, right? Okay, how do we divide? That one might be the hard one. Uh-oh. Where's my marker? One. Nope, this one doesn't work. On the board. Okay. By the way, Ms. Hansel has also brought us some more lotion tissue. Where? Yep. Plus lotion. I'm telling you guys, we're going to be okay for the winter if we last that long. Okay. So if I have f of x equals 3x squared plus x minus 3, and I have, that's a g now. It lost a little bit of the bottom. G of x equals x minus 1. How do I find f of x divided by g of x? You guys ready for this hard stuff? We're ready. We're ready. There is actually a way to do it, but we're not there yet. So far, there it is. Okay, you have about 10 questions of that stuff. Hence why I didn't really do any of it, so it's kind of read on to it. I'd rather talk about the other parts that are more important. Okay? Even and odd functions. That's our main deal today, is even and odd functions. I always wonder why it stopped. Let's start with an even function. I'm going to give you the definition of both. Now, the way I give the definition, you might be all like, what the heck does that say? Because I'm going to put it in the mathematical terms. Okay? So let's say we have this function f of x. Okay? Now, the way you do this for even or odd is the same procedure. You replace the x with negative x. And if it is an even function, after you replace it with a negative x, you will get the exact same function. Okay? Can anybody roughly think of a function that I can replace the x and then come back and be the exact same thing? What's the function that we can do the exact same thing by just replacing the x with negative x? Absolute value of x. Okay, let's check that out. Okay, so absolute value of x. Okay, so let's check to see if it is an even function. Remember, I'm going to replace the f of x with f of negative x. And for those that remember, what does that mean? I'm going to replace everything in this equation that has an x into it to being a negative x, correct? Is the absolute value of x and the absolute value of negative x the same thing? Is this the same thing as the absolute value of x? it is. So did you notice, after replacing the x with a negative x, I got my same exact equation back. Because of that, I know this is an even function. Okay? Let me show you what the math is for an odd function. If I have f of x, I try to replace it with negative x, and I should be able to get, if it's an odd function, its direct opposite. Direct opposite. Just for curiosity, what would be the direct opposite of the absolute value of x? Negative absolute value of x. What would be the direct opposite of 3x plus 4? Negative 3x minus 4. Distributing that negative to the full equation. Does that make sense for everybody? What would make it its direct opposite? It's just putting the negative through the equation. So, can anybody think of an equation that when I replace the x's, it'd be its direct opposite? How about f of x equals x? Oops. Or we could even make him x cubed. Let's make him x cubed. So, really quickly, side note, what would be his direct opposite? Because that's what we need it to be if it's an odd, right? Negative x cubed would be its direct opposite. So if we can make this function negative x cubed by replacing the x with a negative x, it is an odd function. Okay? So, now when I insert something, I usually put parentheses around it. Because once again, negative x cubed and negative x cubed are two different equations. They mean two different things. What is this saying? We're taking negative x and doing what to it? Cubing it. What does this say? I am taking x, cubing it, and then doing what? Timesing it by a negative 1. Do you guys see the difference in the notation of these? Okay? So, but what is negative x cubed? What's negative x times negative x times negative x? Negative x cubed. Is it its direct opposite of what it began? So therefore, this is an odd function. Okay? Does that mean, let's just ask, does that mean every absolute value is an even function? Not necessarily. Does that mean every x cubed is an odd function? Not necessarily. Okay, I'm going to show you by doing some math. Here's another example. Okay. This one requires a little bit of thinking. The work's not too hard, but the thinking's a little deeper. Okay? Does anybody know what the true definition of absolute value is? Go ahead, Cosette. The distance away from 0. Okay? The distance away from 0. So, who else has a distance of x plus 1 away from 0? Negative x plus 1? Okay? If it would have the same distance, it would be negative x minus 1, because that's the same thing as negative, what do these guys both share? Negative 1, what's left over? X plus 1. Notice, give me two numbers. Just give me any two numbers that have the same distance away from the 0. 4 and negative 4. 4 is 4 units away from 0, as is negative 4. Correct? If I think about this, let's call x plus 1 4. Is this not negative 1 times 4? Which is like negative 4. Right? So do you guys understand how this is equivalent to this? They're the same. Because it's an opposite number. Sometimes we have a hard time of thinking x plus 1 is a number. We just don't know what x is. We have an infinite amount of things to plug in for x. Right? I just don't know what it is. So that is a number. So let's pick any number. Pick any number in the world. 10. What's 10 plus 1? 11. What's 10 plus 1? With a negative. Does the absolute value of 11 and 11 have the same distance? Yeah. So you guys see how this is equivalent to this in terms of absolute value? So this would be equal to x plus 1 in absolute value. I could actually say this really equals that. Okay? All right. But notice, that wasn't our equation. We just wanted to talk, right? We didn't check even or odd, did we? Because we just said what would be equivalent to this, right? Is everybody with me on that? So let's actually check it's even. Okay? F of negative x, I believe it was absolute value of x plus 1. Is that what it was? So it would be negative x plus 1 if I try to check it's even. Okay, what is that similar to? Let's pull out the negative. Do you understand that this is equal to that, correct? You guys see how I just pulled out the negative? Because if I distribute it back through, would I get back to the top equation? I would, right? What's negative? So what's the absolute value of negative in parentheses x minus 1? What's that equivalent to? Makes you think a little bit. That's equivalent to x minus 1. Is that what we started with? What did we start with? X plus 1. Is x minus 1 the same? No. So is this an even function? No. This is neither. Because is it its direct opposite? Because what would be its direct opposite? Negative absolute value of x plus 1. Does that make sense? Okay, that would be neither. Let me give you a visual. Okay, since we talked about absolute value, what does that graph look like? It's a V. For those that remember, when you studied it, it's a V. If you recall last year in your study, if you had a V, was it a plus 1? Is that what we studied? On the inside of the absolute value, what did that do? What did that plus 1 do? Shifted this over 1 to the right, didn't it? You guys remember shifting? If it's on the outside, you do exactly what it sees, like if it's absolute value of x, absolute value, right? Plus 1, meaning the plus 1's on the outside, just shifts my graph. Up 1, right? Absolute value of x, and then minus 1 on the outside, that drops it down 1. Just remember that. So it's absolute value of x minus 1 within the absolute value, that moves it to the right 1. Make sense? You guys remember doing that? Okay, I want to share something with you. Okay, think about an absolute value really quick. Here's its graph. Notice some points on here are 0, 0, 1, 1, 2, 2, 3, 3, negative 1, 1, negative 2, 2, negative 3, 3. Correct? Are those all value points on a absolute value graph? Right? Let's think about what we did to check if it's an even function. We replaced our x value with negative x. So what's the opposite of 1? Does it get the same y value, or does it come back to the same function? It does. Does 2 and negative 2 get me back to the same function? 3 and negative 3? Okay. Now, if I checked out the x plus 1 graph, it looks like this, where negative 1, 0 is here, correct? Then we had 0, 1, 1, 2, 2, 3, negative 2, 1, negative 3, 2. Notice, what's his opposite of 1? Negative 1. Did they give us the same result? So right there, just visually, we can tell that it's not an even function. Okay? Something that you guys want to know is, what kind of symmetry does this have? It is even symmetry, that's very true, but we don't call it even symmetry. We call it symmetric about the y-axis. If it is an even function, you will be symmetric about the not even, but the y-axis. Even function is symmetric about the y-axis. Okay, exactly what Daniel just said, if you guys want to write that in your notes as well, is odd functions are symmetric about the origin. Now, sometimes people struggle with understanding what's symmetric about the origin. I'm going to come over here just for the fact that Daniel brought it up. Odd function okay, so let's go ahead and graph something that's symmetric about the origin. If I give you a point, hello young lady, you doing some birthdays? Whose birthday is today?